Hello everyone, today we will be discussing about work and energy. What do we mean by work? Work is done when a force acts upon an object to cause a displacement of the object, where it is a product of the magnitude of the displacement multiplied by the force parallel to the displacement. In order for work to be done, there are three conditions to be met. First, the force is acting on the object. Second, the object must have displacement caused by the force applied. And third, the force, or at least its component, must be parallel with the direction of the displacement. How do we compute for work? We have this formula. W is equal to F times D times cosine theta, where W is the work done, F is the force applied, D is the displacement, and theta is the angle between the force and the displacement. The unit used for work is joules. Since force is in Newton and the displacement is in meter, therefore 1 joule is equal to 1 Newton meter, or 1 joule is equal to 1 kilogram times meter square per second square. Work can be positive, negative, or zero. If the displacement and the force have same direction, the work is positive. If the displacement and the force has opposite direction, work is negative. If the displacement and the force has perpendicular direction, work is equal to zero. Or if there is no application of force or the object is not moving, still work is equal to zero. There. Let us have this example. Displacement is equal to 5 meters, and the force applied on the same direction is 5 newtons. Since force and displacement is in the same direction, therefore work is positive. And then we try to substitute that with our formula. Force is 5 newton times 5 meter. Work is equal to 25 joules. How about if we have this example? Still, displacement is equal to 5 meters. However, the force as applied is in the opposite direction, which is equal to 3 newton. Since the displacement and the force have opposite direction, we have our work here which is negative. So substituting that with our formula, W is equal to negative F times T, where F is 3 newton and our displacement is 5 meters. Therefore, work here is equal to negative 15 joules. The work here done is by friction. Let us have this sample problem about work. Example, a student with a mass of 80 kilograms runs up 3 flights of stairs in 12 seconds. The student has gone a vertical distance of 8 meters. Determine the amount of work done by the student to elevate his body to this height, and let us assume that his speed is constant. So from the given problem, we have this. The mass is 80 kilograms, time is 12 seconds, and displacement is 8 meters. We have to take note that it is vertical distance. So we have here, work is equal to F times D times cosine theta. But instead of force, we have here mass times gravity, since it is vertical. There is a pull of gravity. So then, if we try to substitute the given values to the formula, so mass is 80 kilograms times gravity, which is 9.8 meter per second square, and our displacement is 8 meters, and our theta here, since it is vertical, that is 0 degrees. So then, we will get now, work here is equal to 6,272 joules. Now let us discuss energy. Energy is the currency of nature. It is the ability to do work. And there are many forms of energy like the solar energy, the thermal energy, wind energy, electrical energy, and so on. However, this time we'll just be discussing here two forms, which are potential and kinetic energy. Same with work, the unit used for energy is in joules. And we have here the law of conservation of energy, which states that energy is being either stored or it is being transferred and or transformed. Let us first discuss kinetic energy. It is the energy needed in the motion of a mass. For example, this truck. In kinetic energy, we have two dependent variables, which are here, kinetic energy is equal to 1/2 times mass times velocity squared. So we have two dependent variables in kinetic energy, that is mass and its velocity. Kinetic energy is directly proportional to the square of its speed. Second, we have the form of energy which is potential energy. It is the energy stored because of position or the orientation of the object. This energy is called the gravitational potential energy. It depends on two variables. What are those? We have the mass and its height. The gravitational potential energy is directly proportional to its height. So doubling its height here, it will result to a double gravitational potential energy. Tripling its height will triple its gravitational potential energy. There you go. Let us have this sample for kinetic energy. We have a truck, which is a mass of 10,000 kilograms with a velocity of 8 meters per second. And let us try to find out what is the kinetic energy of this truck. So substituting the value, the mass is 10,000 kilograms. There. And our velocity is 8 meters per second. So then, we have kinetic energy is equal to half of 10,000 is 5,000 kilogram times the square of 8 meter per second is 64 meter square per second square. Therefore, our kinetic energy is equal to 320,000 joules. Let us have a sample problem for potential energy. Our formula is potential energy is equal to mass times gravity times the height. Okay, in this example, potential energy when the object is at the ground is equal to 0 joules. Why? Because the height there is 0. That will give us a potential energy of 0. As it reaches 3 meters height, what would be its potential energy? When that box has a mass of 2 kilograms. So substituting with our formula, mass is 2 kilograms. Our gravitational pull is equal to 9.8 meter per second square, and our height is 3 meters. Our potential energy when you have a height of 3 meters is equal to 58.8 joules. Energy can be transferred or transformed through, first, work. That is due to the application of force by the first object and the resulting displacement of the second object. It could be also through heat. Here, due to the collision between molecules. And third, through sound, by mechanical disturbances in materials. And fourth, we have the electromagnetic radiation that is due to electromagnetic waves such as light. We have what we call the law of conservation of mechanical energy. Mechanical energy is the energy that is possessed by an object due to its motion, that is kinetic energy, or due to its position, that is potential energy. Mechanical energy, it means that is the sum of the kinetic and potential energy possessed by the object. And the sum of the kinetic energy and potential energy is always constant. So we have this example. So the box, which has a mass of 10 kilograms, has a potential energy of 0 as well as kinetic energy of 0 when it is on the ground. When it is brought to a height of 5 meters, there is the highest potential energy. It gains the highest potential energy. There you go. So in this case, our kinetic energy, it is equal to 0 joules. Our potential energy is equal to mass times gravity times the height. So if we're going to substitute that with this formula, we will get 10 times 9.8 times 5. So our potential energy at a height of 5 meters is equal to 490 joules. And the sum of the potential and kinetic energy. Kinetic energy here at a height of 5 meters is 0. Our potential energy is equal to 490. Therefore, the sum of this is equal to 490 joules. When the object is being dropped and it reaches a height of 3 meters, what will happen? There. So our potential energy when the height is at 3 meters, that will be equal to 10 times 9.8 times 3. The potential energy at a height of 3 meters is equal to 294 joules. And so, we will be able to get the kinetic energy. It is falling down. So there must be a kinetic energy. So at 3 meters height, we will be able to substitute potential energy, which is equal to 294. And the sum of these two is 490 joules. So getting kinetic energy, we just get here, that is equal to 196 joules. and is still dropped, and before it strikes the ground, the potential energy is equal to 0, but kinetic energy is equal to a constant of 490 joules. But when it reaches the ground, both potential and kinetic energy are 0. That's all for today. Thank you for watching. See you around.